All right. Today is kind of our last two foundational pieces to the questions I'm going to ask you tomorrow to start getting the answer for our unit circle. So today we're going to look at like what quadrant are our different trig functions positive and negative in based on the building up we've done. Like, does moving right or left give us negatives and positives, and what quadrant did that fall into, etc. And then also this idea of what's called a reference angle. And what it turns out is that all coterminal angles and then all of those that have the same reference angle have the same trig value. And so we're going to work our way into then what is the reference angle. So we don't have to know the answer for all infinite number of angles. We only have to know one trip around a circle. And actually we'll end up learning even less than that. So jumping into today, this little chart that you see right here is something that you are going to get to know and love. I know it seems very weird at the moment. We haven't talked through it, but I will write this next to almost all my questions and or at the top of each of my assignments or whatever to reference it. There is a mnemonic device to help you remember the order and what letters you are seeing in here. And if you don't like my mnemonic device, pick your own. Okay, but you need to remember this because it is so helpful. The mnemonic device that goes with this to help you remember that it goes A, S, T, and C is all students take calc. If you don't like that, pick whatever you want, but you'll hear me refer to it frequently as think through your all students take calc. And that's going to be think through what quadrant it fell into and which of your trig functions is positive and negative in each of those. So what does all students take calc stand for, and what is it supposed to remind us of? Well, what it's going to tell us is which trig functions are positive. So what we are looking at is a picture of what trig functions are positive. Okay. So with that being said, let's figure out what it means and how it is true that what we are looking at. I will get us started here, and then I think you're going to see kind of the pattern. But if we were to consider a triangle that would have gotten us into quadrant one, first of all, to move into quadrant one, we would have had to move to the right, which in the coordinate plane is a positive number. We would have had to move up, which in the coordinate plane is a positive number. We connect back to the origin to put theta, and our hypotenuse was always a positive number. Well, if our triangle is made up of three positive numbers, what did we find out about all of our answers for sine, cosine, tangent, secant, cosecant, cotangent? Positive or negative answers? Positive, right? Because all my options are positive. Every ratio that I would set up is going to be some positive number over some positive number. So what you are seeing here is that all trig functions are positive if our angle falls in quadrant one. We're going to look a little closer as we move to the other quadrants and why it is what it is. So let's move into quadrant two. Quadrant two, I have to move left, and in the coordinate plane, when I move left, that is a negative number. And then I have to move up to get into quadrant two, and a movement up is a positive number, and our hypotenuse is always positive, with theta being at our origin. Okay, so if I start setting up my trig functions from theta, okay, well, sine of theta would be my opposite over my hypotenuse, which would be some positive number over some positive number, right? Which ultimately would be positive. Okay, cosine would be my adjacent over hypotenuse, which would be some negative number over some positive number, which ultimately would be something negative, right? With me? Okay, I'm just doing it symbolically. I'm not putting numbers out there, and I hope that's okay. But tangent then would be my opposite, which is some positive number over my adjacent, which is some negative number, which ultimately would give me a negative answer. So guesses as to what S stands for. Sine is the only positive, right? That is the only positive function in quadrant two, sine only. Now, with this being said, I know that I'm focusing on the first three, sine, cosine, and tangent, like the three we know. But if you think about the reciprocals, it's taking those same two signs and turning them upside down, right? So wouldn't they have the same sign as their reciprocal? So although I do say that it is sign only, it is also, it's reciprocal, right? So also every reciprocal that is associated. Okay, so then moving into quadrant 3, again, I have to move left, which is a negative number, but then I also have to move down, which is another negative number, back to my origin. Hypotenuse is always a positive number. Okay, so setting up our trig functions this time. Sine of theta is our opposite, which is a negative number over our hypotenuse, which is positive. So something overall is going to be negative. Cosine is our adjacent, which is a negative number over our hypotenuse, which is a positive number, which again, ultimately will give me a negative answer. Tangent's the one that's a little tricky in this quadrant because it is opposite over adjacent. Well, my opposite is a negative number, my adjacent is a negative number, and a negative over a negative is ultimately positive. And so you're seeing the T, which you probably guessed, stands for tangent, also cotangent, right? Is the only positive trig function that you will get in quadrant 3. All right, so what's the only positive trig function you're going to get in quadrant 4? Cosine, okay? Just to prove to you that that's true, I would move to the right, which is positive, down, which is negative, connecting back to my origin. The hypotenuse is always positive. Sine being my opposite over hypotenuse would be a negative number over a positive, so ultimately I'd get a negative answer. Cosine, my adjacent side is positive, my hypotenuse is positive, which gives me a positive answer. And tangent is my opposite, which is negative, my adjacent, which is positive, ultimately giving me a negative. So the only thing that is positive in quadrant 4 is cosine, and it's reciprocal. Okay, so that's where we start. I draw my angle. I say, okay, it fell into whatever quadrant. Based on all students take calc, is my answer based on this trig function positive or negative? And now we know. Okay. Questions so far? Okay, so a way that we can kind of use this a little bit, let's just look at what quadrant we're talking about based on the given information. We have to interpret this information just a little bit here. It says find the quadrant in which the angle lies if tangent of theta is less than 0. So I'm going to give us an all students take calc to think about here. Okay. And if they tell me that tangent of theta is less than 0, what does less than 0 tell me about the number for tangent of theta? Negative. Okay. So as you're looking at this, remember what these mean. This means all of my trig functions are positive. Can tangent of theta be negative there? No. In quadrant 2, the only thing that's positive is sine of theta. Can tangent be negative there? Yeah, the only thing positive is sine. So that would be an option. Is tangent going to be negative in quadrant 3? No, that's the only thing positive in quadrant 3, right? So that's not an option. Is tangent negative in quadrant 4? Yes. Okay, so I kind of jumped the gun here a little bit, but what you're going to notice is every single time you are given the sign of a function, you have two options. Okay, it will always work in 2 quadrants. It's always positive in 2 quadrants and negative in 2 quadrants. So then what we're going to do is look at the second piece of information we are given and find the common ground, find the overlap between these two things. So the second piece of information they give us is that cosine is greater than 0. And again, interpreting that, that means cosine is positive. So as I work my way around my all students take calc, everything is positive in quadrant 1. So cosine is obviously positive in quadrant 1. Sine only in quadrant 2. So cosine can't be positive there. Tangent only in quadrant 3. So cosine can't be positive there. But quadrant 4 is where cosine is positive. So that would be its second option. Okay, so do you see what happened? Right? It would be in quadrant 4. So what quadrant would both of these work? Where I could draw this angle? Quadrant 4. Questions? Okay. You try thinking through one with a very similar setup. What quadrant could this angle theta lie? so again, my markings on here, these are just for us to like have a way to think through or to kind of organize our thoughts. This is not like an official thing that you have to draw. If it helps you, use it. My two pieces of information this time, sine of theta, again, less than 0 means negative. So I go through my all students take calc and identify for myself the two places, because it's always two places, that would happen. It is not quadrant 1 because all things are positive there. It is not quadrant 2 because that sine is the only thing positive there. For the first piece of information, we should have picked quadrant 3 and also quadrant 4, tangent only, cosine only. The second piece of information they tell us is that cosine is also less than 0, meaning cosine is also negative. So again, thinking through where that could be happening, obviously cosine is positive in quadrant 1, everything's positive there, and the other place that's positive is the one labeled by cosine, right? So it is negative in quadrant 2, it is also negative in quadrant 3. So the place where this theta could be that would make both of those true, quadrant 3. Okay, questions? So again, understand with each of these signs that they give you, there's always two possibilities. Find the overlap. Okay, so progressing from that, building our way into this. This time, again, we're going to figure out our quadrant to start with, but we're going to move on past that. It says, given that theta is negative 2/3 and cosine of theta is greater than 0, find the cosine and cosecant of theta. So first of all, thinking through my all students take calc, it'll be the same thing. There are two quadrants for each of those pieces of information, but the first piece of information they gave me is in a slightly different format than before. Before they would have used like cosine of theta is greater than or less than 0. But if they just tell me what tangent, I said cosine, tangent of theta is, if it's negative 2/3, it's negative, right? It's just whatever sign is on that number. So the first part that says tangent of theta is negative 2/3, well, the two places, two quadrants where tangent can be negative would be quadrants 2 and 4. Good so far? Just kind of changed up our info there. But that again is just tangent is negative. Cosine being positive, all things are positive in quadrant 1. Cosine is positive in quadrant 4, and I find my overlap. Both of those pieces of information can be true if I draw this into quadrant 4. And that's actually now what we are going to do. So to be able to find cosine of theta and cosecant of theta is now I'm actually going to rely on our triangles. So I'm going to draw a triangle that goes into quadrant 4 because it worked for both pieces of information. And this is where we go back to what we were doing before. To get into quadrant 4, I started the origin. I moved right or left first. So I moved to the right to get into quadrant 4, and I moved down. Connect back to the origin, just like we were doing before. Okay? But now a little bit of interpreting. If they tell me that the tangent of theta is negative 2/3, go back to what we know about SOHCAHTOA and the ratios of our trig functions. Okay, well, in tangent, it is your opposite side over your adjacent side. So if they're telling me that the fraction is 2/3, that means my opposite side is 2 and my adjacent side is 3, and you're going to label that in your picture. Now, here is my strong suggestion to avoid some mistakes here. Notice it did say negative 2/3. I hope you caught that, and I didn't put a negative in there yet. Once you have drawn your picture, I always want you to step back and say, label my numbers by the direction I moved. If I moved left, I'm going to label it negative. If I moved down, I'm going to label it negative. Don't rely on the fraction, okay? There's two reasons for that. 3 should be positive. I moved to the right. 2 should be negative. I moved down. So I'm going to put the negative there. Now that accounts for the negative that was here. Here's the reason I say that you should not like go off of the fraction is because a negative sitting in front of your fraction really could go up to the 2 or down to the 3 appropriately. And if you just guess, you may put it in the wrong place up there if you're not paying attention to the direction you moved. The other thing, which is not in this particular problem, but if you have something like 1/2, that is the same as -1 / -2, which would not show up because that would have simplified out. But if we moved like left and down and you were doing opposite over adjacent, it should be 2 negative numbers, which simplifies to a positive. So rely on the picture to appropriately put the sign on your numbers, okay? Okay, so then we're back to what we know. I've got a right triangle. I've got 2 out of 3 sides. I am asked for 2 trig functions. I find my third side using Pythagorean theorem. And I label my sides opposite adjacent hypotenuse, and I find my trig function. So let's find that third side. Remember, I don't really need the signs in here because everything's going to turn out positive. 2 squared is 4, plus 3 squared is 9, plus 4 is 13. Oops, I said put plus. And it looks like our hypotenuse will not simplify. Is just the square root of 13. Always theta at the origin. Use that to label opposite, adjacent, and hypotenuse. Think through your trig functions. This time they only asked you for 2 of them. They asked you for cosine, which would be your adjacent side over your hypotenuse, which we will rationalize as always. And they asked you for the cosecant. Cosecant being the reciprocal of sine. So I'll do my hypotenuse over opposite. Hypotenuse is 13, opposite is -2. I don't really care where you put the negative as long as there's one of them in there. You can sit out front of the fraction or on the 2, it doesn't matter to me. What questions do you have for me so far? Okay, you try one of those. Pick your quadrant, draw your triangle, label it based off of info given. Appreciate you being comfy, but let's. All right, let's make sure we got our triangle at least into the correct quadrant. The first piece of information they tell me is that a sine is a negative number. Sine can be a negative number in quadrant 3 and quadrant 4. They also tell me that cosine is a positive number. Cosine can be a positive number in quadrant 1 and quadrant 4. So it looks like we're drawing a triangle into quadrant 4 again. So to get to quadrant 4, we move to the right and down. Put my angle at the origin. Use that piece of information they gave us. Remember that sine is your opposite side over your hypotenuse. So I'm going to label my opposite as 1. My hypotenuse is 3. I'm going to evaluate the directions that I moved. Because I moved down here, 1 should be negative. Always force yourself to pause and make that evaluation. Did I move left or down, and do I need to put a negative on any number? Pythagorean theorem to find our third side. So that'd be 9 minus 1 is 8. And then did you catch that that one simplifies? Right, so we should have a side of 2 square root of 2. Yes. Correct. And then 9 minus 1, because the 3 is your hypotenuse. So I would have subtracted 1 to get it to the other side. Yes. The hypotenuse is always positive. Always, always. I feel like you're not convinced. Okay, so 1 squared is 1, yes? They're on opposite sides. Yep. So I would have subtracted to move it across. Yep. And yes, So that's why, again, on the fraction, don't like assign the negative to a particular number. Step back and evaluate. Did I move left or down? And those numbers become negative, and your hypotenuse is always, always, always positive. Okay. All right. So now I have this labeled. Now I just evaluate from here. What is my opposite, my adjacent, and my hypotenuse? And I set up in this one and asked for the remaining ones, which means we should have 5 answers because we started with 1. They already gave us sine. One of those answers, I shouldn't have even needed to set up my triangle. If sine is -1/3, cosecant is -3, right? We can just turn that one upside down. The rest, we're going to go back to our triangle to help us here. Cosine of theta is going to be our adjacent side, 2 square root of 2 over our hypotenuse. Tangent is our opposite over adjacent. So our opposite is -1. Our adjacent is 2 square root of 2. And then remember that we are never allowed to leave a radical in the bottom. So rationalize. On our rationalizing, just a reminder on this, that the square root of 2 times the square root of 2 is 2. Times the 2 that was already there is why you're going to see a 4 in that denominator. And then -1 times the square root of 2 is negative square root of 2. And those 2 and 4 do not simplify because the 2 is inside, the 4 is outside. Reciprocals, secant of theta, we're going to turn that upside down. So 3 over 2 square root of 2, rationalize. 3 square root of 2 over, same conversation we just had down here, square root of 2 times square root of 2 is 2, times the 2 that was out front is why you see a 4 in that denominator. And then turning our tangent upside down to get cotangent, and again, I'm going to go to the unsimplified version, 2 square root of 2 over -1, which I would write just as a negative 2 square root of 2. All right, before we move on from this topic, do you guys have any questions for me? Okay, the second conversation we are going to have today is on this topic called reference angles. And you notice that I only have pictures of an angle that is drawn into quadrants 2, 3, and 4, although reference angles will be a conversation in quadrant 1. If it's like your theta is less than 90, that is your reference angle because it's whatever acute angle gets you back to the closest x-axis. So there are some very important points that I want to highlight for you in the description of a reference angle. A reference angle is the positive, all your answers to reference angles are positive, acute, all your answers to reference angles are less than 90 degrees, angle that is formed with wherever our angle stops, terminal side, and the x-axis. You can only use the x-axis when figuring out a reference angle, okay? So what is the x-axis? Well, in degrees, your 2 options that you would really keep in mind. Your x-axis is 180 degrees over here. And depending on which direction we're headed or how far we've gone, either 0 or 360 degrees on that side. If we're talking in radians, now this one's a little harder for me to draw all the options, but remember it's relative to your denominator, and this one would be pi, like 4 over 4, 3 over 3, 6 over 6. And then a full circle is 2 pi or 0 radians. But 2 pi, we always made double our denominator, 8 pi over 4, 6 pi over 3, 12 pi over 6. Those are the only numbers. Notice you cannot use the y-axis. I'm not going to put numbers on there that we should not even consider the y-axis when talking reference angles. So what you're going to do is you're going to draw your angle, figure out what quadrant it falls into, and then say, how far was it from that closest x-axis? Direction does not matter. Sign will always be positive. So which way you subtract, just whatever's going to give you a positive answer. Okay. Any questions so far? All right. I have given you, and you'll see the same directions on all, I don't know what we have, like 6 examples today. All 6 examples will be set up the exact same way. It'll tell you step number 1 is to draw the angle. Step number 2 is to identify the closest x-axis. And step number 3 is to figure out what the positive difference between those two things are. How far are you from your closest x-axis? So job number 1, which is why we have been practicing this, is to draw your angle, and most importantly, that you draw it into the correct quadrant. Okay, so let's draw 210. 210 should put us into which quadrant? 3. Remember, if we're talking degrees, think in chunks of 90, 90, 180. If I got all the way to the next line, it'd be 270, and we didn't. So this is 210 degrees. So now, closest. You think people make a mistake on that, and I'm trying to stress it a lot? Yes, x-axis. You are only allowed to use an x-axis. So my closest x-axis would be right here, which on this side is called the 180 degrees, right? So theta prime, which is the notation for reference angle, not something you need to be stressed about, but when you see me put a little tick mark, that's why, is how far apart these two angles are. We're gonna call this theta prime. So what is our reference angle here? 30. The difference between 210 and 180 is 30 degrees. Always positive. So if you had subtracted 180 minus 210 and saw that it was a negative 30, that's fine. Understand that you're going to take the positive version of that answer because it is referring to a distance, actually. Always positive. How far are you from your closest x-axis? Okay, let's try one in radians. Again, same 3 steps to kind of work our way through this. And step number 1 is to correctly draw it into the correct quadrant. Using what we have been using, and again, I'm hoping that eventually we kind of work away from this, but marking our axis as how it is based off of this particular denominator would be 4 pi over 4 and 8 pi over 4, double the denominator, right? And thinking about how our angle falls relative to those two particular options. Well, a full circle is 8 pi over 4, and we're supposed to draw 7 pi over 4. We're supposed to be just one away, right? Which, as I'm talking through that, so there's 4 over 4, that'd be 6 over 4. 7 over 4 would put us here. Okay, so my closest x-axis this time would be here. What is the distance away? How far away are we from that? 1 pi over 4, right? And in our conversation about like appropriately drawing it, I kind of already told you the answer, didn't I? Because I said, well, full circle was 8 pi over 4, and we were supposed to be 1 away from that. So our reference angle here is 1 pi over 4. That's how far we are from the closest x-axis. Questions? Okay, we're just going to kind of keep bopping back and forth between degrees and radians here. Well, 6 pi over 4 would actually, I don't want to confuse anyone. 6 pi over 4 would not have a reference angle because it would fall on your y-axis. So it's kind of a different story. 6 pi over 4 is actually 3 pi over 2, if you were to simplify it. If it happens to fall on an axis, we treat it like the quadrantial angles that we talked about a couple lessons ago. So it is a good question. It would just match whatever you would get for this particular angle of 3 pi over 2. Does that help? Okay. So I don't want to say it doesn't have a reference angle. It doesn't, because it falls exactly between the two. But yeah, okay. All right. What happens if my angle is negative? Nothing. Nothing changes. Okay. Start by drawing it, figure out what quadrant you're in, and then we're going to talk about that. We're going to get like make our eyes a little blurry and just kind of ignore the whole positive negative thing at the end. And again, The task is figuring out what quadrant 240, negative 240 falls in. The distance is still 240 degrees. The negative just tells me what angle or what direction to start doing that in, right? So negative 240, start on your positive x-axis. If I go that first line, that's negative 90, negative 180. I'm not going to get all the way to the next line because that would have been negative 270, and I was only supposed to go negative 240. So this is where we're going to kind of, oops, 260. Blur our eyes a little bit. Don't get so hung up on the whole positive negative thing. Again, my closest x-axis is here, which is 180 degrees. And again, don't get hung up on the whole positive negative thing. What is this difference here? 60, right? And everything is positive in the world of reference angles. And so we're just going to say that our reference angle is 60 degrees. That is how far you are from the closest x-axis. Questions? Okay, let's try. Oh, okay. I put this example in here. You guys know we have new books this year. I have never seen a question like this before. It is very specific to this book. I'm going to tell you right now that I don't like this question, for the record. However, if you see it again, I want you to know how to appropriately do this question and not be confused. But know that once tomorrow comes around and we're talking unit circle specifically, you would never see a question like this or need to find its reference angle. But this is an angle that is in radians. How do I know that? I know that because it doesn't have a degree symbol after it. I know that seems a little whatever, but that's true. Okay, so I know it's in radians. Back when we learned about radians, I showed you what 1 radian looked like. It was an angle that opened up the length of 1 radius. Okay. And that's what led us to knowing that it took a little more than 3 of those angles to get half a circle, which we called pi. Yeah? That's where that number came from. And pi is approximately 3.14 whatever. Well, knowing that helps me draw this because I'm supposed to draw 3.6. So if I get from here to here, I've gotten approximately 3.1 something, and I'm supposed to get to 3.6 radians. And like I said, this is this book specific, but I don't want you to ever get confused if you were to see a question like this in our book practices. So then our reference angle goes back to that closest x-axis. Because typically for a reference angle, you don't need a calculator, but right now I'm going to need a calculator because to figure out this difference, I don't really know what that is. It's whatever 3.6 divided by, or minus pi is. The difference between those two. It's like 0.4 something. .4, so we'll just call it 0.46. Okay. So if they do ask you a question like this, you would just have to grab your calculator and add or subtract pi or 2 pi, whichever one happens to be your closest x-axis. There's not really a better way of doing this one. Okay. All right. Moving on to ones that we do need to know. What happens when the angle that is given to us is bigger than a full circle? So here's your example of bigger than a full circle. Now this I absolutely could ask you on Friday, okay? So bigger than a full circle, the thought process of figuring out how to draw this will actually kind of probably, maybe not directly, answer what your reference angle is going to be or how we can figure out what our reference angle is going to be. And there's kind of 2 different methods for this, and I'll talk through both of those. But first of all, how much bigger than a full circle is that? Almost 2 full circles. It's 305 degrees, right? How can I figure that out? Well, just subtract a full circle, right? So if we go a full circle and then, let's see, 305 degrees more, that'd be 665 degrees. So I draw that, right? So there's that 360. And then 305 more, 90, 180, 270, 305 is going to be somewhere in here. You can look at that as one of two ways. You can look at this as the angle 665, or just kind of consider it how much more than a full circle we went. We went 305 degrees more than a full circle. Those would actually be coterminal angles to each other, which both would have the same reference angle. So again, kind of depending on which one you pick. So closest x-axis here in quadrant 4, that's going to be your positive x-axis. Now, if you went this route and you were thinking of it as like 305 degrees, you would think about how much to finish a full circle at 360. How short are we? Yep. Our theta prime, our reference angle would be 55 degrees. If you considered it 665, you would think, how short am I from completing that second full circle? Well, a second full circle would be 360 times 2 or 720. Well, the difference between those two numbers is the same as the difference between 360 and 305. Okay. Either way, you're going to get a reference angle of 55 degrees. Closest x-axis. Questions? Okay, so there is your example of what do we do if my angle is bigger than a full circle? What do I do if my angle is bigger than a full circle in radians? Okay. Yes. Sure. This has the same conversation we just had in degrees. Again, can kind of answer the question for you as we're going. I would label my picture relative to the denominator, 4/4, double the denominator for a full circle, 8/4, and I'm supposed to go 15/4. So after I've completed a full circle, I've gone 8π/4. How much more do I need to go? 7, right? 7π/4 more to get a total of 15π/4. So the same conversation we just had. Full circle is 8π. I need to go 7π/4 more, which would put me into quadrant 4. Did I do that too fast? We're okay. How did I know that 7π/4 is going to fall in quadrant 4? Because it's only one away from a full circle, right? So I'm only 1π, which is your answer right there. We're 1π away, 1π/4, I should say, 1π/4 away from our closest x-axis. Whether I consider this 7π/4, just this part of it, or 15π/4 to complete 2 full circles of 16π/4, 1π/4 away from that closest x-axis. Okay, I think I've got one more for us to do here. All right, let's try reference angle for negative 11π/3. Okay, so negative 11π/3, if I go a full circle, I've gone 6, and I'm supposed to go 11, right? So if I go 3 more, half a circle, I'd be at 9. If I went 3 more, I'd be at 12, but I'm only supposed to go 11. So I'm going to stop in quadrant 1. How far am I from my closest x-axis? I am 5π/3 away, past a full circle, or at 11π/3 away from completing 2 full circles of 12π/3. I am 1π/3 away. So our reference angle here. Okay, glance back over all your radian ones. What do you notice about all your answers to the problems we did with radians? Pi over the denominator. Yeah? I'll show you. These were our answers to the ones that had radians. One of the questions was 7 pi over 4, we got an answer pi over 4. 15 pi over 4, we got an answer pi over 4. Negative 11 pi over 3, we got an answer pi over 3. Do you think that's a coincidence? It's not. No, it is not. It is not if it is a pi over 4, a pi over 3, or a pi over 6. This is always true. Your reference angle is pi over the denominator, which is, I mentioned once upon a time that you were going to like radians better than degrees. This is one of the reasons, is that as soon as you look at this, I can tell you what the reference angle is. Now, do I actually need the 7? Well, yeah, it'll help me know what quadrant it's in, but I don't have to do any thought process to figure out my reference angle. I see a problem in radians, there's my reference angle. See a problem in the radians, there's my reference angle. Done. I don't have to do any like mental math or adding or subtracting or anything. And that's one of the nice things about radians. Okay. I do have to consider this and this to figure out, okay, is it in all students take calc? Which quadrant is it in? But my reference angle is easy. And that will not change if it is a pi over 4, pi over 3, or pi over 6. Why those 3 in particular? That's from our unit circle. And the way those fractions simplify, there is no other option in that quadrant, and it will only ever be 1 away from your closest x-axis. Okay. All right, your assignment tonight is on My Math Lab, and we're going to go to that real quick right now and make sure that it is assigned